Okay, let's just jump right into it. What if aging isn't actually an inevitable fact of life? What if, instead, it's a treatable disease? Today, in this explainer, we're going on an absolutely incredible journey to answer that radical question. We'll be starting all the way down at the microscopic science of our cells and zooming out to the massive global and even theological impacts of literally curing death.
Here's our roadmap. We're going to first cover the hard genetic science of aging. You know, how we define it, track it, and how we might actually stop it. Then, we'll smoothly shift gears into a fascinating ethical discussion about what a cure for aging really means for all of us.
All right, Section 1. Is aging a disease? Rethinking the inevitable.
So, the crucial point we have to ask ourselves right off the bat is this. What if the loss of health as we get older isn't just some natural fact of life, but a disease? A disease we can actually attack at its roots. Harvard geneticist David Sinclair makes this exact argument. He says that by failing to define aging as a disease, we've basically forced ourselves into this futile game of whack-a-mole. We're just treating individual age-related diseases like Alzheimer's or cancer as they pop up, rather than treating the underlying cause of it all.
To really grasp the science here, it's absolutely vital that we define the difference between secondary longevity and primary longevity. Now, secondary longevity is what medicine does right now, right? It's just surviving illnesses so people can reach the end of a normal human lifespan. But primary longevity, that's an entirely different frontier. It's the radical goal of actually lengthening the absolute maximum human lifespan itself by fundamentally altering the mechanics of our biology.
As you can see, modern medicine is currently just compressing mortality to the very end of life. Think of it as rectangularizing the curve. Basically, more people are surviving into old age, which creates this sharp, sudden drop-off at the end. But, and this is key, our absolute maximum biological limit hasn't actually budged at all.
Moving on to Section 2, the epigenetic clock, tracking cellular time.
Now, to understand how we can push past that absolute limit, we really have to separate chronological age from biological age. Chronological age treats everyone exactly the same based on, the numbers on a calendar. But biological age, that reflects our lifestyle, our genetics, and our environmental exposure right down at the cellular level. It perfectly explains why you might see one 50-year-old out there running marathons while another is sadly struggling with severe health decline.
To understand why this happens, we look to David Sinclair's information theory of aging. Think of your DNA as the digital hardware of a computer. It actually stays remarkably intact over the years. But your epigenome, that's the software telling the computer what to do. Over time, that software gets corrupted by cellular stress. The signal degrades, the genes get confused, and that loss of analog information, well, that's what we physically experience as aging.
So, scientists measure this biological aging in two distinct ways using what they call epigenetic clocks. First up is your cumulative epigenetic age acceleration, or EAA. This directly compares you to your peers to see your cumulative deviation over time. The second is your pace of aging. You can think of this one like a cellular speedometer. It literally measures the instantaneous speed of your biological decline right at this exact moment.
Which brings us to Section 3, Interventions to Slow Aging, Flipping the Longevity Switch.
Right now, we are fighting this battle on two fronts. On the lifestyle side, we have evidence-based stressors, things like fasting, cold exposure, and high-intensity exercise. On the medical side, we're seeing emerging interventions. We're talking metformin, rapamycin, and NAD+ boosters. Both of these sides basically work by stressing the body just enough to activate ancient survival networks. We're essentially tricking our biology into defending itself.
But wait, it goes beyond just pills and exercise. Researchers are now exploring these cutting-edge partial reprogramming protocols. By using specific proteins called Yamanaka factors, scientists are acting like hackers, trying to reboot our cellular software back to a youthful state. The goal here isn't just to slow the clock down. They want to actively run it in reverse. Crazy, right?
All right, Section 4, the 3 views on longevity, how society reacts.
Research outlines 3 totally distinct cultural camps when it comes to extreme life extension. First, you have the cautious crowd. They're deeply worried about justice, global resources, and, frankly, the dangers of playing God. Next up is the exuberant middle. These folks aren't necessarily trying to live forever, but they are seeking the fountain of aging well to maximize their health span. And finally, we have the futurists. They want to eradicate death entirely and aim for indefinite biological immortality.
Looking at the futurist perspective, some truly believe that using technology to achieve biological immortality is actually humanity's highest moral obligation. From this specific viewpoint, a natural death is viewed as a tragic disaster. So pouring resources into ending it, to them, that is the most noble pursuit possible.
In extreme contrast, though, the cautious view argues that radically extending lifespans could literally be morally wrong. Why? Because of the severe strain it would place on justice and global resources. Ethicists like Garrett Hardin and Daniel Callahan point out that focusing heavily on primary longevity caters to this highly individualistic desire, a desire that could completely ignore the devastating impacts on the wider global community.
Let's dig into that in Section 5, Societal and Environmental Costs, the Unintended Consequences.
Think about it. If only the wealthy can afford to live forever, we could see a rapidly destabilized world. We're looking at massive, biologically enforced gaps between the rich and the poor, not to mention skyrocketing healthcare costs as a percentage of GDP. Furthermore, there are serious generational equity problems where resources are essentially hoarded by the old. In a society of immortals, we could even see a world with almost no children being born.
The crucial point here is the environmental strain. This is highlighted by a meta-analysis showing that 7.7 billion people is the Earth's maximum sustainable population limit, and, well, we're already well beyond that number. Because populations made up of older, individual households consume significantly more resources, radically extending lifespans would place absolutely maximum stress on our already fragile global environment.
Finally, we arrive at Section 6, the Ethics of Immortality, Defining Humanity. When we view this whole topic through a theological lens, the research outlines that some Christian perspectives argue recognizing our mortality is actually essential to being human. This view warns that trying to erase our natural limits through technology steps into the very dangerous territory of ultimate pride. It fundamentally disconnects us from the natural order.
There's this profound quote from bioethicist Leon Kass that perfectly captures the fear that removing death might actually destroy the very essence of humanity. He asserts that our limited lifespan is exactly what gives our existence its urgency, its meaning, and its shape. So to eliminate mortality might just be to create a species that is no longer fundamentally human at all. Contrasting those tech-driven futurists, historical texts like St. Francis of Assisi's Canticle actually embrace mortality. They see it as a natural, accepted part of the created order. By referring to Sister Death, this theological perspective views the end of life not as some failure of science or a tragedy that needs to be cured, but as a harmonious, expected transition right within the natural bounds of nature. So, we've explored the fascinating mechanics of the epigenetic clock, the very real societal costs of extreme life extension, and the deep, deep ethical divides it creates. And I want to leave you with this final, provocative thought. If science truly unlocks the secrets of our cells and makes aging entirely optional, would you actually choose to live forever?